All right, welcome to this explainer on the rail grinding machine. We've got our hands on the RGM exam prep guide, and well, our entire goal here is to help you absolutely ace those upcoming departmental exams. So let's get right to work.
To make sure this material actually sticks for the exam, we're going to break the RGM down into 5 logical buckets: bogies and motors, fire prevention, fuel logistics, the corrugation analyzer, and finally, safety systems. Okay, let's jump right into bucket number 1, bogies and grinding motors, which is really the core operation of this whole machine.
Take a look at how these independent wheels are set up. You've got to remember they are strictly kept in a locked and raised position while the machine is just idling. And what's kind of brilliant about this mechanical setup is the flexibility it gives the operators. Even when the bogies are lowered and actively grinding, those motors can be independently raised or lowered. So if the crew spots an obstacle on the track, boom, they just lift the motors right up and the bogies keep on rolling without missing a beat.
Now, this brings us to a major operational constraint, and seriously, highlight this in your mental notes because it is a guaranteed exam question. Why are operators completely forbidden from lowering these bogies on curved tracks? Just think about the physics of a massive train navigating a tight bend for a second. Here's the deal. The buggy's wheelbase is completely different from the main wagon's wheelbase. So if you try to drop those buggies while you're navigating a curve, the wheels simply aren't going to align with the rails. They won't sit right, and that misalignment, yeah, that's going to cause a catastrophic derailment. You must only ever lower the buggies on a perfectly straight track, period. Moving on to section 2, fire prevention and water, or how we keep from burning everything down. As you know, grinding metal on metal throws off an absolutely massive shower of sparks. So before those grinding motors even touch the rail, the machine goes on the defense by laying down a wet, protective barrier. It uses the tie spray and ditch spray systems you're seeing here to pre-soak the vulnerable wooden sleepers and the dry vegetation in the ditch before a single spark even flies. You'll definitely want to commit this equipment checklist to memory. The machine isn't just relying on preventative sprays, it is armed to the teeth for active fire suppression. We're talking a 30-horsepower pump, a dedicated water cannon to blast distant spot fires, manual hoses, standard extinguishers, and an automated fire detection system to alert the crew instantly. But to power all of those defensive sprayers and cannons across miles and miles of track, the RGM needs a staggering amount of water. Just look at the sheer scale of the storage tanks on this wagon. Which brings us to our first absolutely critical number for the exam. Exactly 75,000 liters. Lock that number in. That is the total onboard water capacity you have to know. 75,000 liters of water dedicated entirely to making sure this machine doesn't leave a literal trail of fire in its wake. All right, section 3, fuel and supply logistics. Basically, what it takes to keep this industrial beast moving. To meet its massive energy demand, the RGM's fuel tank holds roughly 21,000 liters of diesel. Just like that water capacity we just talked about, this 21,000-liter figure is a vital spec to memorize. It completely dictates how long the machine can stay out there grinding before it has to head back for a refill. And refilling isn't exactly like pulling up to your local gas station. Since railway consumer depots, or RCDs, are spaced out roughly 250 to 400 kilometers apart, operators have to meticulously plan the refuel schedules way in advance. Miscalculate your burn rate? Well, you end up with a multi-ton machine completely stranded on the main line, which is an absolute operational nightmare. And to absolutely guarantee the machine never just sits there idle during those kinds of logistical emergencies, there's a designated advance fund of exactly 5 lakh rupees. That's right, basically a 500,000 rupee emergency wallet just for the urgent, on-the-spot purchase of diesel or spare parts. The railway knows that an idle RGM costs way more in lost time than this fund, so they empower the crew to keep it moving at all costs. Let's pivot to section 4, the rail corrugation analyzer, which acts as the diagnostic brain of the whole operation. Developed by an engineer named Stuart Grassi, the RCA is absolutely vital. You can't just blindly grind away at the rail, right? The RCA is constantly measuring the rail corrugation, those microscopic waves and wear patterns on the steel, while the machine is physically moving. It feeds real-time data back so operators know exactly how deep of a cut to make. It ensures you grind off just enough steel to fix the rail, but not a single millimeter more. If there's a visual identification portion on your test, pay close attention here. Notice exactly where the RCA is mounted, right on the front axle of the rear drive truck. It sits incredibly close to the surface, just continuously scanning the track geometry as it rolls forward. Finally, Section 5, Safety and Dust Collection. Let's talk environmental control. First up is the obstacle detection device, hovering right above the rail. Think of this clever little sensor as the machine's eyes on the ground. If it picks up any physical blockage ahead, like debris or severe track defects, it shoots an immediate warning signal to the operator. That split-second alert allows for super rapid corrective action, like instantly lifting those grinding motors we talked about earlier, saving the machine from catastrophic damage. But safety isn't just about avoiding crashes. It's also about environmental control. Grinding steel obviously kicks up massive clouds of fine iron dust, which is incredibly harmful to human lungs and the surrounding ecosystem. So how on earth does the RGM safely process this toxic byproduct while hurtling down the track? It uses a highly efficient 3-step onboard dust collection system. Step 1, powerful vacuums suck the iron dust directly from the grinding area right into a specialized collection chamber. Step 2, that dust is systematically emptied into heavy-duty secure bags. And Step 3, those bags ensure the safe, contained disposal of all those iron filings into a designated trackside trench, keeping the crew and the local environment totally safe from contamination. You really got to watch out for this one specific hazard, though. Over time, that collected iron dust inside the machine can absorb moisture and actually harden into massive, dense clumps. And because iron is so heavy, these hardened masses can physically break off the undercarriage and crash right down onto the tracks. It literally creates a brand new obstacle out of thin air. So constant vigilance and regular cleaning of those chambers are absolutely mandatory. As we wrap up this explainer, I've got an active recall challenge for you. Think back to these 3 numbers: 75,000, 21,000, and 5 lakh. If you can confidently spit out what each of those represents right now, you are in fantastic shape for exam day. Mastering the RGM isn't just about checking boxes on a test. It's about understanding how we maintain the very arteries of our infrastructure. But it does leave us with a slightly terrifying question. With so many volatile elements all packed together, flying sparks, massive water tanks, thousands of liters of diesel, and heavy iron dust, what happens when just one of these interconnected systems fails out in the middle of nowhere? Think about that as you prep for your exam, and good luck.